Complex numbers are very important in fields such as electronics. In this video, we find the complex zeros of a cubic equation with real coefficients using the factor theorem. The one thing to remember is that if all the coefficients of an equation are real, any complex solutions will come in conjugate pairs. We already explained why in our previous video. Our cubic equation is a positive polynomial with all coefficients real, so it will always cross the x-axis at least once. We are going to use the factor theorem to find this real solution. We are going to divide our cubic by the factor z minus x to obtain the remaining quadratic. We will use the quadratic formula to find the other two solutions. Stop the video here and see whether you can guess the real solution of our cubic. Right, our cubic has one real solution. The clue here is to try numbers that go exactly into the constant term minus 4. Why? Well, when we write the cubic in factorized form, we can see that the three solutions multiply to give us negative 4. The real solution is a factor of negative 4. Our real solution is 2. We can confirm this by substituting 2 into our cubic. 8 take away 16 plus 8 equals 0, so 2 is a solution. This means that z minus 2 must be the factor. We can find the remaining quadratic by dividing the cubic by z minus 2 or simply by inspection. We know that minus 2 times c equals minus 4, so c must be 2. The coefficient b is a bit more tricky. Pay attention to the linear term of our cubic 6z. That comes from multiplying minus 2 times bz plus 2z. If 6 equals minus 2b plus 2, then b must be minus 2. All we have to do now is solving the quadratic using the quadratic formula. Substituting x equals 1, b equals negative 2, and c equals 2. Carefully, the discriminant inside the square root, b squared minus 4ac is negative 4. This has two complex roots, plus and minus to I. Dividing both the real and the imaginary part by 2, we obtain 1 plus I and 1 minus I. Our two complex solutions come in conjugate pairs as we expected. We can visualize the real solution too by looking for the x-intercept or the zero of our graph. Because the graph only crosses once, this confirms that the other two zeros are complex. Complex numbers are very important. Master algebra and complex equations step by step. Visit mathsadvice.com for more details. If you enjoyed this video, subscribe to this channel and hit the notification bell to receive updates.